This is the Unit 7 review key. Last test, ladies and gentlemen. Here we go. So we have function f of x equals 3 to the x power. I'm going to make a table of values and then graph it. So if I put negative 2 in for the x, I'm going to get 1 over 9. If I put negative 1, I'll get 1/3. 0 is 1. 3 to the first is 3. And 3 squared is 9. I'm not going to do all those points. I'm just going to do the ones that are easily found. I can do the 1/3 because I kind of guess it. I got 0, 1. I got 1, 3, and 2, 9. So this is going to look like this. Okay. Now if I want to do the inverse of that graph, I'm going to take the x values and put them in for the y section of the table. I'm going to take the y values and put them in for the x. So my y values were 1 over 9, 1/3, 1, 3, and 9. My x values are negative 2, negative 1, 0, 1, and 2. Now I can graph those points for my inverse. So again, I'm just going to do the 1/3 and negative 1, which is about there. I can do 1, 0, 3, 1, and 9, 2. My graph will look like this. Okay. All right, so that's the inverse of my first graph. Now we want to find the characteristics of both graphs. So the first graph, the 3 to the x power, and the inverse of that on the right-hand side. So we're going to go all the way down the line for the first graph, the f of x graph. So looking at our graph, it's a increasing, okay? So it's a growth function. So our domain is from negative infinity to positive infinity because it's all the x values that exist on the graph. For the range, the graph starts at 0 and goes up to infinity. My asymptote, where the graph does not cross, is the x-axis, and the equation for that is y equals 0. The x-intercept does not cross the x-intercept nor touch it, so there is no x-intercept. The y-intercept, where it crosses, we can kind of see that in the point right here. Oh, hold on. Right here. And that is 0, 1. Our intervals of increase or decrease. Since it's a growth function, it's going up, so it's increasing by the domain. So across negative infinity to infinity. There we go. And lastly, my end behavior. So as the x value goes to the left, towards negative infinity, the graph is going down towards 0. As the x values go to the right, towards positive infinity, the graph is going up towards positive infinity. And there's my characteristics of the first graph. Now the second one. So in this case, my domain, the x values that exist, the graph does not go past the y-axis. So it starts at 0 and then goes towards infinity. It's only on the right-hand side of our coordinate plane. For the range, it goes all the way down and all the way up. So it's going to be negative infinity to infinity. My asymptotes. The asymptote is on the y-axis this time. The y-axis has an equation of x equals 0. All right. This does cross the x-intercept, or the x-axis right there, at 1, 0. It does not cross the y-axis anymore, because that's where the asymptote is. The graph is increasing over the domain of 0 to infinity. And the end behavior. So as x approaches, now this time it's not negative infinity because it doesn't go that far. It approaches 0. As it approaches 0, the graph goes down towards negative infinity. As the graph goes to the right towards positive infinity, the graph is also going up towards positive infinity. And there are my characteristics of an exponential and a logarithmic or an inverse equation. Let's do it again. So this time if I put negative 2 in for the x value and all those values for my x term, I'm going to get 9, 3, 1, 1/3, and 1/9. So negative 2 comma 9 is here. 1 comma 3 is right there. We'll go here. So now this is a decaying function. It's going down. Again, for my inverse, I switch the x and the y values. So the negative 2, negative 1, 0, and 1 and 2 used to be my x's. Now they are my y's. And I have 9, 3, 1, 1/3, and 1/9. So 9 comma negative 2 is right there. Oh, right there. There we go. 3 comma negative 1, 1 comma 0, 1/3 comma 1. So about there. So this graph looks like this. That's its inverse. Okay, so again, we do the same thing. We're going to find the characteristics of the first graph and then find all the characteristics of the second graph. So in this case, the domain, like the one above it, is negative infinity to positive infinity. The range, again, is going to be 0 to infinity, the y values that exist. The asymptote is still the x-axis, so it's y is equal to 0. Still does not have any x-intercepts. Does have a y-intercept of 0, comma 1. It's labeled in your table of values. This time it's decreasing over the domain of negative infinity to positive infinity. And your end behavior. So as x goes to the left towards negative infinity, the graph is going up towards positive infinity. And as x goes to the right towards positive infinity, the graph is going down towards 0. It doesn't go past 0, it just goes towards 0. Now let's look at the characteristics for the inverse. Domain is going to be, so it doesn't cross the y-axis. So the domain is 0 to infinity. The range, the y values that exist in the graph goes up and it keeps going down. So it's negative infinity to positive. The asymptotes, this time it is the y-axis, which has an equation of x equals 0. There is an x-intercept. It's 1 comma 0. You can see that in the table, right in the middle there. All right. There is no y-intercept. The graph is still decreasing over the domain of 0 to infinity. And then finally, your end behavior, as x goes to the left, as it goes to the left, it's going towards 0. The graph is going up towards infinity. As the graph goes to the right, towards positive infinity, the graph is going down towards negative infinity. That's your end behavior. Okay. So here we have our equations. We're going to write the inverse. So to write the inverse of any inverse, you have to switch the x and the y first. So it's going to be x equals 3 to the y. Now we make this exponential equation into a logarithm. So it's going to be log base 3 of x is equal to y. All right. Next, again, switch the x and the y. So it becomes log base of 1/3 of x equals y. Okay, switch the x and the y. So log base 27 over 3 of x equals y. And lastly, switch the x and the y. Log base 2 of x equals y. Very simple, straightforward. Same pattern for each one. Okay, now do the same thing for this, but this time we're going to do the reverse. We're going to make a log into an exponential equation by doing the inverse. So again, we switch out the x and the y. Okay, then we smash the log. The 3 goes to become the base of that exponent. So we have 3 to the x power equals y. Switch out the x and the y. Smash the base, or sorry, smash the log, the base becomes the other side. 5 to the x equals y. Okay, switch the x and the y. So now that because this log doesn't have a base, it's automatically 10. Smash the log, base becomes the base for the exponent. 10 to the x equals y. All right, now this next one, we haven't really shown you these types of problems. This is also a log problem. It's a natural log. Natural logs, anytime you see just ln, always has a base of e, the letter e. Okay, so otherwise it works the same. So we switch out the x and the y. Okay, smash the natural log. The base goes the other side, so we have e to the x equals y. So although it's a little bit, looks a little different, all the rules still apply the same way. Okay. Some transformations. Okay, we want to graph and label a new function that has some transformations. Okay, let's explain how the transformations worked. I'm going to label them as 1 and 2. The first one was a horizontal shift. I'm going to go to the right by 1. Second one is a vertical shift. I'm going to go down by 4. Okay, so those are our 2 transformations. Now we have to graph them on this coordinate plane here. So I'm going to use these points. I'm going to just use kind of 2 of them to help myself out and make them go to the right by 1 and down by 4. So here's 1, 2, 3, 4. That's 1 point. Here's the other point. The other point's going to be someplace there. So here's my graph. Okay, notice that you don't go past the 1 value because that's how much my graph moved over by. And that's my new equation, or sorry, my new graph. I'm going to label it k of x. Okay, notice it does say graph and label, which is why I had to label the function. So please make sure you do that on the test. Same idea. We're going to describe our transformations first. Here's 1 and 2. 1 is a horizontal shift. Going to the left by 7. And 2 is a vertical shift. Going up by 3. Okay. So I'm going to take my points again. Going to the left by 7 and up by 3. 2, 3, 4, 5, 6, 7. 1, 2, 3. Here and here. Okay, here's my graph. Again, I don't go past -7 on my y-axis value. Okay, so make sure your graph is somewhat accurate. And again, this is k of x because it asked us to label it. So don't forget to label. All right, solving some equations. Okay, this is an oldie but goldie. All right, so we have 2x cubed minus 50x. Out of these 2 terms, you can take out a 2 and an x, and you're left with x squared minus 25. Okay, the x squared minus 25 is the difference of 2 squares. I'm going to keep the 2x in there. It gives me x plus 5 and x minus 5. Now I have 3 separate factors, 1, 2, and 3. I set them all equal to 0. And solve all of them. Divide by 2, I get 0. Subtract 5, I get -5. Add 5, I get +5. These are my 3 answers for A. Part B, I have 2 things multiplied together that are also different to 2 squares. There's no point in multiplying them out. Please do not do that. Okay, x squared minus 49 is x plus 7 and x minus 7. X squared minus 9 is x plus 3 and x minus 3. I set all of them equal to 0. I solve all of them. X will equal, if I subtract 7, negative 7. If I add 7, positive 7. Subtract 3, negative 3. And add 3, positive 3. Next, radical equations. First, to solve this, I have to add the x to the other side so that I get the square root sign by itself. So the square root of 6x minus 5 is equal to x. Now that the square root sign is isolated, I can square both sides of my equation to cancel out the square roots. So I have 6x minus 5 on the left and x squared on the right. I want to keep the x squared value as a positive, so I want to subtract 6x and add 5. So they cancel out over there. I have x squared minus 6x plus 5 equals 0. With this, I can now factor this. Two numbers that multiply to be 5 but add up to be negative 6 would be negative 5 and negative 1. Negative 5 times negative 1 is positive 5. Negative 5 minus 1 is negative 6. I set both of my factors equal to 0. I solve for x. Now, because I have a radical equation, I should check my answers to make sure they work. So if I put 5 in for both x's, I get 6 times 5 is 30. 30 minus 5 is 25. The square root of 25 is 5. And 5 minus 5 is 0, so that checks out. Next, we do the 1. 6 times 1 is 6. 6 minus 5 is 1. The square root of 1 is 1. And 1 minus 1 is also 0. So both these answers will work in our problem. Next, part D. Again, I have to get my square root sign isolated, so I have to add 9 to both sides. So I have the square root of negative x plus 6 equals x plus 6. Okay, now, like before, now that the square root sign on the left is isolated and by itself, I can square both sides of my equation. The square root and the square root will cancel. I get negative x plus 6 equals. On the x plus 6 squared on the other side, I have to multiply that out. So x plus 6 times x plus 6 gives me x squared plus 12x plus 36. All right. I'm going to move the stuff on the left to the right. So I will get x squared plus 13x plus 30 equals 0. All right, now I can factor this. Two numbers that multiply to be 30 and add up to be 13 are 10 and 3. If I set these both equal to 0 and solve, I will get negative 10 and negative 3. I have to check these answers in my original equation. Negative 10 in for x gives me negative times a negative 10, which is positive 10. 10 plus 6 is 16. The square root of 16 is 4. And 4 minus 9 is negative 5. So I'm going to write that down so I remember it. On the other side, negative 10 minus 3 is going to be negative 13. And that is not true. Wrong. So I'm going to cross out the negative 10. Let's just check the negative 3 to make sure that works. If you put negative 3 in for the x, negative times a negative is a positive, so we have positive 3 plus 6 is 9. The square root of 9 is 3, and 3 minus 9 is going to be negative 6. Now if I put negative 3 on the other side, negative 3 minus 3 is also negative 6, and that checks out. So negative 3 is my only true answer. All right. I'm going to do some technology stuff. So we're going to open up Desmos and do some graphing. Okay, so we want to find the points of intersection for these two equations. Now, for these two equations, it's really important you put them in correctly in your Desmos so that you get the right answer. Here's my first equation. Here's my second equation. Okay, and then we're going to graph it a little bit. So it looks something like this. Oops. Oh no, I lost my pen. We'll come back. Hate when that happens. All right, let's find our graph here. Here we go. So we have our red graph that looks like this, and our other graph that looks like this. Oh, hold on. Let's back up, try that again. The graph looks like this. That's close enough. Now we're going to find the points of intersection. There's actually 3 points of intersection. So we've got to find them all. So here's the first one. So I have negative 2.122, comma, negative 5.063. I have that one at 0.063, comma, negative 4.25. And then the last one is 2.03, comma, negative 3.757. So I have to list all the points of intersection because that's what I'm asked to find. Okay. All right, so that one's done. Next, I have a new equation down here. I have 3 to the x power minus 6 times x plus 1. Okay, let's look at the graph. It's a little bit skewed, so it looks a bit like this. I want to find the x-intercept. There's 2 of them. There's negative 0.941, comma 0. And there is 2.86, comma 0. And then there's one y-intercept right there. 0, comma negative 5. And that's graphing it. Okay. Next, number 10. Johnny starts a savings account at the local bank for his daughter. Starts the account with $1,000, and the account has an annual interest rate of 4%. Okay. I'm going to write a function that describes that amount of money in terms of years. So let's do amount over time is equal to the initial value, 1,000, and then 1 plus, and turn 4% into a decimal, so 0.04, and then to the t power. There you go. So if I want to find the nearest cent how much money would be in the account after 18 years, I do 1,000, 1 plus 0.04 to the 18 years. So let's get rid of this equation and put that in. So I have 1,000 times 1 plus 0.04 to the 18th power. And there we go. $2,025.82. Okay. Next, in 2005, there were 285 cell phone subscribers in the town. Number of subscribers increased by 7.5% since 2005. So we're going to put, let's do subscribers over time equals the initial amount of 285. It's an ugly 5. All right, so we're adding, because we're increasing, plus 0.075 to the t value. So now we have to figure out the nearest whole number, how many subscribers will be in this town in 2020. So we started in 2025 to 2020. That is 15 years. So you have 285, 1 plus 0.075 to the 15th year. So 285, 1 plus 0.075 to the 15th power. Gives me 843 new subscribers. Notice it said so whole number, it didn't say decimal, so we round down. All right. Next, the population of Detroit is 675,000 and continually decreasing. Okay, since the year 2000. Right, a function describes the population decrease. So we have population over time equals 675,000. Now in the past we were increasing, so we added, now we're decreasing, so we're going to subtract by 0.0127 to the t power. So if we started in 2000, we're going to be going to 2030. So here we go, 675 1 minus 0.0127 to the 30th year. So on our calculator we have 675 3 zeros, 1 minus 0.0127 to the 30th power, and we get that number. So we get a population of 460,021. That's all we got. All right, almost done. A few more to go. All right, so now we have half-life of a chemical isotope. So we had started at 50 milligrams. We're gonna cut it in half each time we have a 6 seconds lapse. Okay, so half of 50 is 25. Half of 25 is 12.5. Ooh, so let's do this. We got 12.5 divided by 2. Gives me 6.25. 6.25 divided by 2. 3.125. 3.125 divided by 2 is 1.5625. Ooh, that's a lot. All right. Now, the tricky part about this is the 6 seconds part. So that changes your t value at the end of your function. So we have a function of c of t is equal to the initial amount of 50 milligrams. Milligrams. All right. A half-life. So I'm taking half of it away. So 1 minus 0.5 to the t divided by our 6 seconds. Okay, so that is our function. All right, in all the other cases we had above, it was always by year or by day or whatever it was. I think it's by year, annual interest rate. Yeah, so every year. So there's only one value as a time frame. Now it's every 6 seconds. So it's not just one, it's half-life is every 6 seconds. So we divide the t value by that 6. So to figure this out after 45 seconds, we do 50, 1 minus 0.5 to the 45 divided by 6. So in our calculators, we do 50 times 1 minus 0.5 to the 45 divided by 6. So our value is 0.276. I'm going to do that, milligrams. Okay, there we go. All right, same idea, half-life. So we're going to start off with 256 divided by 2. 75. No, that's not it. 256 divided by 2. 128. $128 divided by 2. 64. Some of the other ones I can do in my head. So half of 64 is 32. Half of that is 16. Half of 16 is 8. All right, so again, we're going to do our function. So we have c of t is equal to the initial amount, 256. Since we're still dealing with half-life, we have 1 minus 0.5. And this time, our time frame is 25 seconds. So we do t divided by 25. So we have 256, 1 minus 0.5 to the 60 divided by 25. So we put that in our equation. We have 256, 1 minus 0.5 to the 60 divided by, oops, come on, get in there. Don't like that. Divided by, there we go. 60 divided by 25. Some problems. Okay, so we have 48.5 milligrams left. Okay, and that kind of fits in because 60 is someplace in here, and 48 is someplace between 64 and 32. That makes sense. All right. Next, a particular colony of bacteria triples the number of cells every 4 minutes. Again, that 4 minutes is an important piece. All right, the bacteria colony population starts with 10 cells. So we have 10, and we triple it. So 10 times 3, because tripling is times 3, is 30. 30 times 3 is 90. 90 times 3 is 270. Now that's getting a little bit big for me. 270 times 3, nope. Oh, no. There we go. Times 3 is 810. And 810 times 3 is 2,430. Okay, so that also changes our multiplier, our common ratio. So we start with 10. We don't have a 1 plus or minus anything because we're talking about tripling. So we're going to multiply by 3 to the t over 4 minutes. Okay, so now if we plug that in with our 30 minutes, we have 10 times 3 to the 30 over 4. 10 times 3 to the 30 divided by 4. So we have a lot of bacteria, yeah. 37879, and that's where we're going to stop. Okay, because we can't have a decimal for number of bacteria because it's not part of a bacteria, it's all of bacteria. So we're going to always round down for this, and that's our final number. All right, last thing, we're doing some transformations. Okay, so let's labeling. Let's get rid of our calculator over here. So we have 1, 2, and 3 transformations. The first one is a vertical stretch by 2. The second one is a reflection over the y-axis. And 3 is a vertical shift going up by 7. Okay, it's reflection over the y-axis on 2 because it's inside the function. It's not in front of the function. If it was in front of the function by the first 2, it would be reflection over the x-axis. B. There's 1, 2, and 3 different transformations. Number 1, this is your reflection over the x-axis. The second one, this is a horizontal shift. And it's going to go to the left by 4. And 3, this is a vertical shift. And it's going down by 5. C, there are 4 things happening. 1, 2, 3, and 4. First one is a reflection over the x-axis. 2 because it's a fraction being multiplied. It's between 0 and 1. It is a vertical compression. By 2/5. 3 is a horizontal shift. To the right by 7. And 4 is a vertical shift. Up by 2. Last problem. Last problem. There is 1, 2, 3, 4 changes. 4 transformations. The first one, this is a reflection over the y-axis. 2, we're multiplying by a whole number bigger than 1 on the inside of the function. This is a horizontal compression. By 2. 3. Adding on the inside, this is a horizontal shift. To the left by 5. And 4, this is a vertical shift. Up by 9. And there you have it. Good luck reviewing, good luck on the tests, and that's it.